Okay, so how many people know how oil is actually made? Or the better question, how it's formed? Anybody? No? So, well, first to start off, you have a first, this is the first time we see offshore drilling occur. Late 1890s, started in California, moved to the wetlands down in Louisiana area, which then expanded offshore into the Gulf of Mexico. So actually, oil is tiny plants and animals called plankton that died between 10 to 600 million years ago. So they fall, what they do is they die, they fall to the ocean floor, and then thousands of years go by, they get covered in sand and mud, which forms an oxygen-free, I guess you could call it like an just oxygen-free area where they, under the sand and mud. So over millions of more years, you get heat and pressure, which compacts and solidifies it into either solid oil, gas, or natural gas. So everything just naturally forms. So that's how oil's formed. This is two main ways that oil is discovered. The first, magnetic surveying and mass magnetic anomalies, pretty much the differences in the ocean floor. And it'll send back an ultramagnetic wave when it finds it back to the boat. And then the second is seismic surveying, also known as sparking, which is shown in this picture right here. So they drag a, almost like a transmitter that sends shock waves to the differences, and it maps it out and it shows the differences. And this is exactly why these waves is why it's bad. So this is actually how the oil is, the main source of oil is pumped. So you have a boat that goes by, and then once they find where the area is, they drill 4 wells, and then through a core sample, if it's found, they drill a production well. And then this lasts, what they build the rig, and then it lasts over 10 to 20 years until it's not profitable. Like I said before, the shock waves that they send down, it damages many sensitive marine species. There's also acoustic pollution, which affects the blue whale and then many other ones. And that's just a picture of, I think, a seagull after an oil spill. That's the BP oil spill. So another reason why it should not be happening. This is what happened. This is the pollution from an oil rig. You got the black carbon you see here, which contributes to climate change. And then you have this stuff right here spilling out is the stuff we see, drilling muds, the brine waste, the deck runoff. So pretty much what the drilling muds are is it's the lubrication for the cooling of the drill bit and the pipelines. So everything once, because when you drill, you pull the pipe up out of the flow line, and then everything, it spills out onto the deck. And then they just wash it right off the ocean, as you can see down there. And then brine waste, it's brackish water, they call it. It's a different salinity that's produced in the production of oil on the rig. So it changes, that gets spilled out into the ocean as well. And it changes the, I guess, the chemical breakdown of salt water. So it changes that as well. And then the drilling muds also contains drilling fluid. There's metal cuttings. There's approximately 90,000 metric tons of this drilling fluid that gets dumped into the ocean by one rig. And there's about 4,000 rigs just off the coast of the Gulf of Mexico. And in these metal cuttings, there's chromium, there's mercury, there's carcinogens such as benzene, which also contaminate the the bluefin tuna in the Gulf of Mexico. And also, all this right here are all the oil platforms that you see. So it also, in Louisiana, there's thousands of miles of this pipeline that they lay, and it goes in to because they have to pump the oil back onto land. So this causes the coastal erosion that we see. And then this is the BP oil spill. About 4.9 million oil or barrels spilled into the Gulf of Mexico. I think it was about 57 million per day. No, sorry, that's wrong. And there's estimated still 26% still remaining that they didn't get. And as I said before, there's 4,000 wells that operate on the U.S. federal waters, Gulf of Mexico, Alaska, Texas, coast of Louisiana. And as far as actual production, we see that offshore drilling is not going to affect foreign oil dependency, as we use 8 billion barrels a year, and it won't lower the gas price until 2030. And even when it comes to 2030, it only decreases it by a few cents per gallon. So, as we see here, this is the breakdown of oil that the U.S. uses. So we consume, from 2005 to 2030, this is how much foreign oil we use and then U.S. oil that we produce. And at the top in yellow is the new offshore drilling. That's what it will contribute to our oil consumption, how much we'll get from new oil drilling, which isn't much in the overall. And since 1981, it's been already banned in some areas of California, Virginia, North Carolina, South Carolina, Georgia. These are all known as environmental sensitive areas. And in October 1st, 2008, it was lifted, this law. So now they do drill in these areas, making it worse for the environment, the marine life, and everything else. And that concludes my presentation. Any questions?
Mike, I'm not sure, but one point, my initial question was going to be, is there a better solution than offshore drilling? And then I'm wondering, what you're saying was the little yellow part that you showed up there, was
Yes.
that can you go back to it?
Yeah.
Is that all that we get from offshore drilling?
Mm-hmm. If we continue, yes. So 200,000 barrels per day is what we're getting from offshore drilling, and we've only gotten 18 million, barrels of oil from offshore drilling, which isn't on a yearly basis.
I just assumed it was a much larger proportion, and that's why we had to do it. Yeah. So a better solution is?
Alternate forms of energy like natural gas, which also raises the other question, fracking.
Can't solve them all. But.
Yeah, and the alternative like biofuel, wind, that type of stuff would be better. It does, banning offshore drilling will cause an effect on a financial level and as far as jobs, but if we can get rid of it, we can take that and, like I said, try and do other forms of energy as far as.
Thank you.